Good morning, Year 5, and welcome to another week of division. Today's lesson we are going to be looking again at dividing with remainders, and throughout this week we are going to be addressing any misunderstandings that we might have with division. If you've understood division really well last week, then this is just a great opportunity to practice throughout the week. Let's get started. This piece of work belongs to Lila in 5E. Lila, I'm so proud that you have spent the time to work out how to partition those numbers and then divide them and work out the answers. That's really going to help you this week when it comes to the bus stop method. I'm going to award you 2 dojo points for aspiration. This piece of work belongs to Alana in 5T. I was really blown away, Alana, with how you have listened to the lesson, but also how you have partitioned your numbers. I can see clearly from your work that you have understood division, and I know that you're really going to enjoy the bus stop method and practicing it this week. I'm awarding you 2 dojo points for aspiration. This piece of work belongs to Esme in 5W. Again, I was really impressed with how Esme has put her jottings down the bottom to support her when it comes to looking at the multiples of 8. Well done, Esme. I'm awarding you 2 dojo points for aspiration. And this piece of work belongs to George K in 5P. George, I was really impressed with your reasoning within each of your chilies, but also just how hard you have worked to work out each of those questions. Well done. I'm going to award you 2 dojo points for aspiration. Your first starter task that I would like you to complete is on the board. There are 3 questions, and they are all division questions. Look at number 2. I wonder what you could do to work out that missing number. Pause the video now and have a go, and we will come back and show you the answers. Here are your answers for your starter task. Have a look on the board and mark yours against my ones. Now, if you look at number 2, you can see that to work out the missing number, you just had to do the inverse. The inverse of division is multiplication. So you would have just had to do 1,100 times by 5. Okay, let's get started with that lesson. Our learning objective for today is again dividing a 4-digit by a 1-digit with remainders. Just like I mentioned on Friday, this week it's really enabling us to practice our skills that we learnt last week in a variety of different questions. But today our focus is remainders. So let's get started. We're going to have a go at this question together. 5,291 divided by 4. Again, I've got my place value chart alongside, but the main focus will be using our bus stop method. Give it a go. So here's our bus stop method over here. And in our place value chart, we have the correct amount of place value. So we've got 5,000s, 200s, 9 10s, and 1 1s. So again, just like we would ask ourselves, how many groups of 4? So we can see here, can't we? If we focus mainly on our bus stop methods, how many groups of 4 go into 5? Well, you know the closest you can get is 1 because 1 times 4 is 4. You wanted to get to 5, so therefore this then becomes 12 because we had 1 left over, so we moved it over to here. So let's say that again. So we asked ourselves, how many 4s go into 5? We knew that the closest we could get to was 1 because 1 times 4 is 4. But we had 1 remaining, so this now becomes 12. Now I know at home you know this. How many 4s go into 12? Well done. 3. We got that into exactly the even amount, didn't we? So we've got nothing to move over into the 10s now. However, we're now asking ourselves how many 4s go into 9? How many groups of 4 go into 9? What's the closest you can get in the 4 times tables without going past 9? Well done, 2, because 2 multiplied by 4 gives you 8. But again, we wanted to get to 9, so we have 1 remaining, don't we? So we move that 1 over to here, and that becomes 11. So how many groups of 4 go into 11? What's the closest you could get to 11 without going past it? So let's think 4, 8, 12. Well, it can't be 12 because that's past 11, so it must be 8. 4, 8. And we know that that is 2 because 4 times 2 gives you 8. So 2, because 4 times 2 gave us 8, but we wanted to get to 11. So what's our remainder? Let's count on 8, 9, 10, 11. Our remainder is 3. The answer to this question is 1,322, remainder 3. I've got a question on the board that says, there are 349 people at a wedding. They are sitting at tables in groups of 8. How many tables are needed? Well, of course, we know that the division we have to do is 349 divided by 8. So I've gone ahead and done that down here. And the answer was 43, remainder 5. So I've said, well, we need 43 tables then. But I want you to pause the video and have a think. Can I just ignore the remainder of 5 when we're talking about tables and people? Have a think. No, of course, we're going to need 44 tables, because just because it's 43 remainder 5 doesn't mean you can just ignore the remainder of people at a wedding, can we? We have to make sure that there's a correct amount of tables that would fit everybody, a bit like at school. If there were 43 remainder 5 children, we wouldn't just ignore the remainder 5, we would sort a table out for those children. Now it's my turn to have a go at a question. So, the question is 1,721 divided by 5. Now, to support me, just like I mentioned on Friday, I've created my jottings down the side of the 5 times tables. The first question I would ask myself is how many 5s go into 1? Well, I know that I can't do that because this one here is smaller than that 5. So what I'm going to do is I'm going to pop my placeholder here a 0, and then 1 is left over, isn't it? Because we weren't able to find it. So that now becomes 17. How many 5s go into 17? Well, what's the closest that I could get to 17 without going past it? It's going to be this, isn't it? 15. And that's 1, 2, 3. That's 5 times 3. So that would be 3, because 5 times 3 is 15, but we wanted to get to 17. So from 15 to 17, we had 2 left over, didn't we? So that now becomes 22. Again, we go back to the 5 and we say, how many 5s go into 22? Have a look at your jottings. What's the closest you could get to 22 without going past it? Well, I can see that it would be 20, and that's 1, 2, 3, 4 times 5. Again, don't forget that we didn't quite get to 22. So whatever's left, we have to move it over into here. So we got to 20, but we wanted to get to 22, therefore a 2 will go over here because we had 2 left over, didn't we? And now we're asking ourselves, how many 5s go into 21 this time? So what's the closest we could get to 21 without going past it? Well, again, it's going to be 4, isn't it? Because 4 times 5 is 20. And now this is when we have our remainder. So we wanted to get to 21, but we got to 20. So what would our remainder be? Well done. Remainder 1. The answer to this question would be 344, remainder 1. Chili 1, here is your first question. Here is a method to solve 4,894 divided by 4 using place value counters and short division. Again, like I mentioned in my Friday's lesson, if you think that you can move past this place value counters method, you could just move straight on to a bust up method. And basically what you've got to do is use one of these methods, or both, to calculate these 3 questions. So Chili 1, this is your first question. Pause the video now and have a go at that. Chili 2, this is your final question. It says, muffins are packed in trays of 6 in a factory. In one day, the factory makes 5,623 muffins. How many trays do they need? How many trays will be full? Think about that. And why are your answers different? Pause the video now, Chili 1, and have a go at that. Chili 2, this is your first question. There are 459 children in a school. They are sitting at tables in groups of 7. Mo says we will need 65 5 tables. Do you agree with Mo? Explain your answer. Now remember, our focus is remainders. If there is a remainder of children, you can't just forget about the children that are left over, can you? So have a think about that. And here is your second question for Chili 2. It says, how many ways can you complete the calculation using all of these digit cards, so 2, 3, 4, and 5, so that there is a remainder of 1? And what do you notice? So pause the video now. If I've gone too fast, you can rewind it. That's not a problem. And Chili 3, I'm about to show you yours. Chili 3, your first question says, I am thinking of a 3-digit number. When it is divided by 9, the remainder is 3. When it's divided by 2, the remainder is 1. When it is divided by 5, the remainder is 4. What is my number? Again, just like we would at school, this is a lot of trial and error. So your paper might look a bit messy because you're experimenting, but that's what it's supposed to do, so don't panic. Pause the video now and have an experiment with that. Remember, it's a 3-digit number. And your final one, Chili 3, is an always, sometimes, or never question. It says a 3-digit number made of consecutive descending, so it's going down digits, divided by the next descending digit, always has a remainder of 1. Have a look here. This is an example. Consecutive descending means it's going 6, 7, 5, just like 4, 3, 2. So 7, 6, 5, and then the next descending number would be 4 because 1 less than 5 is 4. And they're saying that that is 191, remainder 1. How many possible examples can you find? So they've shown you an example here. Pause the video and have a go at that. And now it's time to check your answers. Again, if you are not ready, pause the video or rewind me. I'm going to give you time now if you are ready and you've just unpaused this video to go and get a different colour pencil or pen ready to mark your answers. Chili 1, here are your answers on the board. So your first answer was 1,322, remainder 3. Your second one was 823, remainder 2. And your third one should have been 2,340, remainder 3. Okay, Chili 1, this is your final question. So what I did here was I worked out 5,623 divided by 6, and the answer that I got was 937, remainder 1. So they will need 938 trays because you can't just forget about this remainder 1. However, the next question was, how many trays will be full? Well, we know that full trays make up 6, don't they? So a full tray, you would have 937 trays that will be full because the other one would have a remainder of 1 and it wouldn't be a full tray. Okay, Chili 2, this is your first question. Do you agree with Mo? No is the answer. I haven't written an explanation because I would like you to send those into the Year 5 email address. Have a think about, well, why wouldn't you agree with Mo? Perhaps it's got something to do with the remainder. And Chili 2, it's just given you an example that you could use here. There will be lots of different combinations. So for an example, you could have had 325 divided by 4 gives you 81, remainder 1. I wonder how many different combinations that you got. And Chili 3, I've just cut the question off because I just want to show you the answers. These are your possible answers for the what am I question. So you could have had any of these numbers. Well done if you got this, because this was a lot of trial and error, so that shows great perseverance. And Chili 3, the final one for you was, it was sometimes, and the possible answers are written down here so that you can have a look. Again, Chili 3, if you've worked through those, well done, because it took a lot of perseverance. From today at 8 AM, I have set you all an arena session to have a go at. It is starting today at 8 and ends Wednesday at 3 PM. I'll be looking out for the leaderboard so that I can give shout outs to those children and dojo points. Good luck.
Monday's lesson is complete. I'll see you here tomorrow for another lesson on division. Bye, Year 5.